In this particular session, we are going to discuss computer architectural classifications, and this classification was made by M.J. Flynn. He has made this computer architecture classified mainly into 4 categories: SISD, SIMD, MISD and MIMD. So, while discussing these particular 4 different classification models, so let me tell you what about regarding these abbreviations. We are having multiple abbreviations I have used in my diagrams. So, IS means instruction stream, DS means data stream, MM stands for memory module, SM stands for shared memory, CU stands for control unit and PU stands for processor unit. So, these are the full forms. So, now let us go for the SISD computer model. What is SISD? Means single instruction stream and single data stream. So, that is the full form of this SISD computer model. Now, we know that a program resides in the computer's memory for execution, and a program consists of instruction as well as data. So, at first the instruction which is going to be executed will be made available to the control unit, and this is known as instruction stream. Control unit will decode the meaning of the instruction, and the decoded version of the instruction will be made available to the processor unit to execute that instruction, that means to perform the intent of the instruction. To execute the instruction, it requires the data on which it will be operating. So, data will be coming from memory module to the processor unit. After it is getting executed, result will be produced and that result will be written back onto the main memory. So, that is why this data stream, this line has made bidirectional in all the four diagrams, and this instruction stream is unidirectional because only instruction will be read from the memory to the CU, and then the processed version of this instruction will be made available to the PU for the execution. So, this is known as the SISD computer architecture. Only one instruction stream, single instruction stream and single data stream. The example for this particular model was with one functional unit and with multiple functional units. So, in case of one functional unit, the architecture is IBM 701 and IBM 1620. In those days, this particular model was implemented in this particular computers. And in case of multiple functional units, the computer numbers are IBM 36091 and CDC 6600. So, this is the number of these particular computers. Okay, now let me go for the single instruction stream and multiple data stream. This single instruction stream means a single instruction will be made available to the control unit, and control unit will decode that one as it was doing in the earlier case also, and the decoded version of this instruction stream will be made available to the processor units in parallel who are working. So, all the processor units will get the same instruction stream as it has been shown, and it will be operating with the different or same data streams, fetching them from the memory module. These memory modules, multiple memory modules are there ranging from MM1 to MMM, and all these memory modules will be under one umbrella known as the shared memory. So, from the shared memory, data streams will be going, and these data streams will be made available, to the processor units for their operations on the decoded version of the instruction. In this way, this particular operation will take place. This sort of SIMD computers, later in your syllabus you will be finding that we used to call these models as array processors. Let us suppose that is one instruction called say array, matrix mul. Okay, matmul. So, one instruction say matmul. So, in that case what will happen, the same instruction, only one instruction matrix multiplication or matmul will be working with different rows and columns of two different matrices. So, as a result of that, the same instruction after getting decoded will be operating on different row and column pairs in parallel. It can operate. So that's why it is called array processors. Okay. And as an example, I can go for Iliac 4 and Staran, very famous names, these two, Iliac 4 and Staran. So they are nothing but the array processors, and this is one of the real embodiment of this particular architectural model proposed by MJ Flynn. Next one is MISD computer architecture. In case of MISD, you know the full form, that is a multiple instruction stream, single data stream. So in this case, what will happen? Multiple instructions will be made available to the control units. So control unit will decode those instructions, and then to get those instructions intent getting implemented, it will be passed to the respective processor units, and processor unit will have a single data stream, and after being processed, this data stream will be processed by this instruction stream, say IS1, and the derived partial or the original data will be made available to the processor unit 2. It will again work with this particular instruction stream IS2, and the derived or partial or copy of the original data will be made available to the next processor units. In this way, from this PUN, ultimately the result which has been produced will be made available or will be written onto the shared memories, on the shared memory in one of the memory modules. So in this way, this particular operation will take place. That means instructions are in multiple, but only one data stream will be applicable, will be available, on which these instruction streams will be working. So this particular model is not having any real embodiment in our practice. So that is the MISD computer architecture. So the last one is MIMD computer architecture. In this case, you can find that we are having this multiple instruction streams are coming. They are getting processed in the control units, and the processed version or the decoded version will be made available to the processor units for execution on different data streams that they will be available, and they are coming from the shared memory consisting of multiple memory modules. So this is known as multiple instruction stream and multiple data stream computer architecture. Multiple instruction streams are there and multiple data streams are there. So that's why this particular architecture is having such a name. So now in this way it will work, MIMD computer architecture. MIMD computer architecture can be of two types. One is a loosely coupled, another one is a tightly coupled. Tightly coupled means these data streams will be coming, some of the data streams might be coming from the same module. So what will happen? So who is reading at first and who is writing next? You see, we are having the bidirectional arrow. That means the data will be read and result will be written, and that result might be the data stream for the another processor units. So who is writing at first and who is reading next, or who is reading at first and who is writing next? So they are very much interdependency is working there. So they will be known as the tightly coupled model. In case of loosely coupled model, all these data streams will be available from separate memory modules. So there is no interdependency that who is reading or who is writing at first or vice versa. So there is no dependency. In that case, it will be known as the loosely coupled computer model. So tightly coupled and loosely coupled. Actually, loosely coupled computer model, you just realize, try to realize, this loosely coupled computer model can also be thought as multiple SISD computers operating in parallel. Multiple SISD computers operating in parallel. So this operation is being taking place multiple number of rows in parallel. So loosely coupled MIMD computer architecture can also be thought of as multiple SISD computers are working. So this is the main logic, and in this case the example is UNIVAC 1100 and borrows D825, where the real embodiment of this particular architecture in our practice. I think we have got all these modules, how they are working and what are the differences between them. I have discussed each and everything in details. along with the respective example computer names here. So I think you have learned the classification model as proposed by M.J. Flynn, and in the next videos we will be talking about the other computer organization related subjects. Please be with us, and thanks for watching this one.